Hello everyone. In this video I am going to explain these concepts of trigonometry which are significant for class 11 and 12. For this, let us consider one Cartesian plane and a circle of radius AO such that AO is equals to r units. Here point A is x comma y and we are drawing one perpendicular AC on x-axis such that in triangle AOC, angle AOC is theta. Things to observe is the direction of this theta. Here I have indicated anti-clockwise direction. In trigonometry, anti-clockwise direction is considered as positive, whereas clockwise direction is considered as negative. So from this triangle AOC, we are getting OC is equals to x and AC is equals to y. And from the trigonometrical ratio, we are getting sine theta is equals to AC by AO. That implies AC is equals to OA sine theta, and OA is the radius of the circle, therefore r sine theta. Similarly, cos theta is equals to OC by AO, and that implies OC is equals to OA cos theta, and that is r cos theta. If we consider the circle of radius 1 unit, that means a unit circle, then AC is equals to sine theta and OC is equals to cos theta. Here AC is y and y is sine theta and OC is x, that is cos theta. Therefore A, that is x comma y, can be written as cos theta comma sine theta if it forms one angle theta in anti-clockwise. Therefore we can also write cos theta comma sine theta. Now let us consider one more angle with same measurement theta but in clockwise direction, and let us name this point B. Being this angle and this angle equal, so this perpendicular from B to x-axis will touch this point C itself, and these two triangles will be congruent. Therefore the coordinate of B will become x comma minus y because of the downward direction of y-axis. Now in triangle BOC, with the previous concept, we are getting OC is equals to OB cos theta and BC is equals to OB sine theta. But in triangle BOC, this theta is negative. Therefore, this can be rewritten as OB cos of minus theta, and this will be rewritten as OB sine of minus theta. Thus, OC is equals to OB, that is 1 unit for this case, that means cos of minus theta, and BC, OC cos of minus theta, and BC is sine of minus theta. And OC, here it is x and BC it is minus y. Therefore x is equals to cos of minus theta and x is equals to cos theta, that is cos theta. Y minus y is equals to sine of minus theta, and y here is sine theta and it is minus y, therefore minus of sine theta. So we get this result. that cos of minus theta is cos theta and sine of minus theta is minus sine theta. Now for the second part of the video, let us consider this Cartesian plane with a circle of radius 1 unit and a point here with coordinate minus x comma y as it is in the second quadrant. And this total angle is 90 plus theta, 90 for this quadrant and theta here. So from the previous concept, we can also write this minus x as cos of 90 plus theta and y as sine of 90 plus theta as any point P. If the coordinates will be x comma y, it can be written as, and if it is forming an angle say phi, then it can be written as cos phi comma sine phi, that we have already discussed. Similarly, this total angle is 90 plus theta, therefore we can write minus x is equals to cos of 90 plus theta and y is equals to sine of 90 plus theta. So from A, if we draw a perpendicular AC on x-axis, then this angle will become 90 minus theta as this is theta and this total is 90 degree, therefore forming angle AOC 90 minus theta. So in triangle AOC, which is a right angle triangle, OC is equals to cos of 90 minus theta into OA by the ratio of trigonometry, and OA being the radius of the circle, which is 1 unit, so 1 into cos of 90 minus theta, and cos of 90 minus theta is sine theta. So we are getting OC is equals to sine theta. Similarly, we shall get AC is equals to OA into sine of 90 minus theta, and OA is 1 and sine 90 minus theta will be cos theta, and that implies AC is equals to cos theta. And notionally OC is equals to minus x, that is the length, the magnitude of OC will be sine theta, but notionally it is minus x. Therefore if we equate this one and this one, then this minus we shall exclude here as this OC is the magnitude, therefore we can write cos of 90 plus theta is actually minus sine theta. Similarly AC, this y, this is the magnitude and this is here sine 90 plus theta, so sine 90 plus theta, therefore cos of 90 plus theta is minus sine theta and sine of 90 plus theta is cos theta. One more thing to realize here, any angle in the second quadrant will be written as 90 plus theta or 180 minus theta. So in second quadrant we can observe that cos of 90 plus theta gives a negative result and sine of 90 plus theta gives a positive result. So cos in second quadrant will be negative and sine in the second quadrant will be positive. Consequently, tan 90 plus theta can be written as sine 90 plus theta by cos 90 plus theta, and which results to sine 90 plus theta as a positive and cos 90 plus theta as negative, and here we shall get cos theta by minus sine theta, and that is minus cot theta. So we can observe In second quadrant, where angles are represented as 90 plus theta, cos provides negative result, sine provides positive result, and tan provide negative result. That means only sine provides positive result. So in second, we say second quadrant is the quadrant of sine, because only sine provide positive result, whereas cos and tan, these two ratios provide negative result. On the other hand, in the first quadrant, all the ratios provide positive result. So we write all, and second quadrant, it is sine. From these two results, now we can define the next result, that is cos 180 plus theta. This can be written as cos 90 plus 90 plus theta. Now if we consider this 90 plus theta as a single entity, then it is in the form of cos of 90 plus 90 plus theta. Then we can write this as minus sine of 90 plus theta, and sine of 90 plus theta is cos theta, thus it will become minus cos theta. Hence we can write cos of 180 plus theta is equals to minus cos theta. Similarly, sine of 180 plus theta is equals to sine of 90 plus 90 plus theta. And again, if we consider 90 plus theta as a single entity, then sine of 90 plus 90 plus theta can be written as cos sine of 90 plus 90 plus theta. We can write this, and cos of 90 plus theta provides minus sine theta. Thus, we can write sine of 180 plus theta is equals to minus sine theta. So we can observe these two results here. Cos of 180 plus theta minus cos theta, sine of 180 plus theta minus sine theta. Now 180 plus theta means any angle in the third quadrant. So in the third quadrant, we can observe cos provides negative result, sine produce negative result. Consequently, tan of 180 plus theta will be sine of 180 plus theta by cos of 180 plus theta, and being both are negative, we get minus sine theta by minus cos theta, that is positive result tan theta. So in the first quadrant, we have seen all the trigonometrical ratio produced positive result. In the second quadrant, we have seen only sine produced positive, but in the third quadrant we could see cos and sine both are producing negative result, whereas tan is producing positive result. So the third quadrant is the quadrant of tan, because in the third quadrant tan theta produce positive result. Now with the similar procedure, any angle in the fourth quadrant can be written as sine of 270 degree plus theta, because 90 plus 90 180 plus 90 270. So any angle here will be in this form 270 plus theta, and this can be written as sine of 180 plus 90 plus theta. Now if we consider 90 plus theta as a single entity, then sine of 180 plus theta, this is in this form, and this is nothing but minus sine theta. So we can write minus sine 90 plus theta, and sine 90 plus theta we could see it is cos theta, so minus cos theta. Therefore we are getting sine 270 plus theta as minus cos theta. Now let us come to cos 270 plus theta. So cos 270 plus theta it can also be expressed as cos 180 plus 90 plus theta, and that is in the form of 180 plus theta, that is in this form, and cos 180 plus theta is minus cos theta. So we can write minus cos of 90 plus theta, and this cos of 90 plus theta can be written as minus sine theta. So minus and here minus sine theta, and it produces a positive result sine theta. Therefore, cos of 270 plus theta is a positive result, that is sine theta. So, thing to observe, here sine in the fourth quadrant produces negative, cos in the fourth quadrant produces positive. So since sine is negative, cos is positive, so tan will also become negative, because tan is the ratio of sine by cos. So one negative, one positive, therefore tan will also become negative. So in the fourth quadrant, sine is negative, tan is negative, only cos is positive. Thus we say that fourth quadrant is the quadrant of cos. So all sine, tan, cos. Here also we can observe that we are moving anti-clockwise, because in clockwise we consider, remember in trigonometry, whenever you are considering clockwise, the angles will be negative, and in anti-clockwise angles will be positive. Here also we move anti-clockwise. So if we move anti-clockwise, in the first quadrant all the trigonometrical ratio is considered as positive. In the second quadrant, only sine will produce positive result, tan and cos will produce negative result. In the third quadrant, sine and cos produce negative result, whereas tan produce positive result. And in the fourth quadrant, sine and tan produce negative result, and cos produces positive result. Now let us see. We have already studied that in the first quadrant all the trigonometrical ratio will produce positive, second sine, third tan, fourth cos. Now how the angles will be represented? In the first quadrant, any angle will be represented in the form of 90 minus theta, as this total angle is 90, so any angle will be 90 minus theta. In the second quadrant, any angle will be represented as 90 plus theta or 180 minus theta. 180 minus theta. In the second quadrant, 180 plus theta, or this total angle is 270 degree, so therefore 270 minus theta. And the fourth quadrant will be, this total angle is 360 degree, therefore 360 minus theta or 270 plus theta. So the ratios for 360 minus theta, 270 minus theta and 180 minus theta can easily be derived from the previous concept. I am just showing one. For example, we are going to find out 270 minus theta. So 270 minus theta can be written as 180 plus 90 minus theta. Now we can consider this 90 minus theta as a single entity, and it is in the form of 180 plus theta. So sine of 180 plus theta is minus sine 90 minus theta, and sine 90 minus theta is cos theta, therefore the final answer is minus cos theta. And we can observe 270 minus theta is the angle of third quadrant, and in the third quadrant only tan is positive. Sine and cos will produce negative result, thus we are getting a negative cos for sine. Similarly, we can derive for the rest of the ratios. Thus we are getting these required results and these results. I hope this video is helpful for everybody. Thank you, and if you have any doubt, please write it in comment. Thank you all.